You may have pressed the Node-RED icon on your Raspberry Pi desktop and been a little disappointed to have seen nothing but a console screen that almost appears to freeze. But do not be deterred. You are only a few clicks away from what I believe is one of the most exciting environments you could come across today. This is your access to a simple but powerful interface that provides you with the tools to monitor and control the physical world around us. It's a convenient gateway to a massive new technology that is now becoming cheaper and more readily accessible. I am of course referring to the Internet of Things, or IoT as it's known. And Node-RED is software that's rapidly developing into a popular platform for device, data and information manipulation. This video will introduce the Node-RED editor and how it operates on and controls the Pi. It will show you how quickly links can be made to and from external feeds and how third-party software can augment the basic Node-RED installation. It will also show you how Node-RED allows you to rapidly develop graphical apps that allow you to control your Pi from a mobile. We will then explain how the Pi fits into your IoT environment at home and the basics of other key supporting technologies such as Node.js, JSON, JavaScript and MQTT. One word of warning. This video was filmed at the end of 2016, but as with all such videos, it's likely to be out of date even before it's uploaded. We've tried to include all of the current techniques, tips and tricks that should help you to get a working platform as quickly as possible, but do be aware of how rapidly technology is changing. This video only uses open source software that can be downloaded onto the Pi. Many of the services can be replaced or augmented by cloud-based technologies. These may be mentioned, but our aim here is to demonstrate how everything can run from a Pi. Your learning is based on your individual pragmatic control of every feature. We introduced the Internet of Things in a previous video, Our Connected World, and how this term refers to a future transformed by devices that monitor and collect data from almost anything, anywhere. The data is used for direct control, but could also be amalgamated and processed to produce further information. We mentioned basic examples, such as climate control and security systems, but then discussed the more profound implications of massive data processing and information management, what is called big data. These activities are promoted by rapidly developing technology combined with dramatically falling prices. The Pi can perform all of the functions required by IoT. It has inputs that may be connected to read sensors. It has outputs used to control devices. It has communications, and finally can be programmed to emulate intelligence. The control of all of these aspects is where Node-RED comes in. Node-RED is a little like Scratch on steroids, in that it's a powerful, extensible graphical programming environment. It was developed by IBM in Hursley, Hampshire, and only released in late 2013, about 3 years ago. Its homepage, nodered.org, already has over 1,000 contributions for download, and there are a rapidly growing number of sites providing service, help, and support. If you're put off by terms such as extensible, environment, and interface, then please do stick with it, as all should become much clearer in the next few minutes. This may be your opportunity to conquer the world without having to become involved in coding at all. Node-RED will let you paddle in the coding shallows, or, if you wish, dive right in. There is no need to understand every stage of this demonstration at the moment. The idea is to describe the desktop, how it operates, and demonstrate how easy it is to rapidly design complex systems in a simple graphical interface. Until Node-RED arrives, a good deal of what is shown here would have taken some time and some serious coding to achieve. This is the basic default Node-RED design page. It is in fact a web page running on your Pi and will be familiar in style if you have already used Scratch. The palette is the panel on the left. It is a list of coloured boxes called nodes, sorted under headings such as input, output, functions, social. On the right is another panel with info and debug tags. In the centre is the main design area, and the basic idea is that nodes are clicked and dragged into this area, as many as you want, and all are connected by clicking on these small grey circular points and pulling out these orange elasticated wires. Outputs only connect to inputs, but you can connect any number of wires to any point. Interconnecting nodes like this produces what is known as flows. Clicking on a node and it's highlit in an orange glow. Wires dutifully follow the nodes as they're repositioned, and here is a lovely feature. Nodes with both inputs and outputs may be simply inserted into a connection like this. Delightful. There is a temptation to try and right-click on a node or wire to delete it, but this just invokes the response from the browser. To delete a node or wire, highlight it and press the delete key on the keyboard. Clicking and dragging around a group of nodes selects them to be repositioned, or again, by pressing on the delete key, removes them. This happens immediately. There's no "are you sure" confirmation. Mousing over any node in the palette produces a quick description, and clicking a node in the flow displays a fuller description under the info tag here on the right. Holding down the control key and tapping the plus and minus keys zooms in and out in the usual browser manner, and the sliders around the side of each pane operate in an expected way. That completes flow connection properties. Now, to achieve something. It's traditional to do a Hello World demo, and who are we to fly in the face of tradition? It will reveal a little more about these nodes and what they do. Drag out an inject node and a debug node and connect them. Clicking once on the inject node displays this information under the tab on the right-hand pane, and double-clicking it provokes a flyout that provides a menu of options and setup information. For the inject node, the default payload is a timestamp, so let's just leave it at that at present and select Cancel. Double-clicking on the debug node produces a similar flyout, with the only option here being Output Message Payload or Output Message Complete Message Object. Once again, we will leave the simple default in place and just note that term Payload. Returning to the flow editor, we see that both nodes have small blue circles on them. These indicate that they have been modified in some manner. To save and activate the changes, we need to click on the red Deploy button, and this green drop-down appears to confirm that all is well. To see any activity, click on the Debug tab, which is clear. To cause any activity to begin, we need to initiate a flow, and here this is achieved by clicking on this side extension of the inject node. This causes a timestamp to be sent from the grey inject node to the olive-coloured debug node. This is confirmed by the message appearing on the right, under the debug tag, and the green confirmation of the action dropping down from the top of the screen. In fact, we can repeat this process as often as we like. This confirms that our desktop design editor is functioning correctly, which is satisfying. We can mute this debug by clicking on its extension button. That retracts it to show it's disabled. No debug message appears, and enabling it again. As a side point, the timestamp appears in the debug area. This is what's known as the Unix epoch, the number of seconds since the 1st of January 1970. Notice that even just a slight clicking and dragging of a node causes the blue spot to reappear. This can be cleared by clicking on the Deploy button again. Double-clicking on the Inject button again and using the pull-down to select String from the Payload option and inserting the classic words Hello World and pressing Done changes the Inject. The blue circles remind us that the change has taken place, so press Deploy. Then click the Inject extension to reveal Hello World in the debug. Job done. We have seen how these two nodes operate, how to enter the setup information and clear the blue dot created by these changes by pressing the Deploy button. No changes are recorded until the Deploy is pressed. All of the debug details are revealed in the tab, and these can be deleted by clicking on this ClearLog Dustbin button. As another example, we could double-click on the Inject node again and this time select Interval. Set it for, say, 3 seconds. Tick the Inject at Once Start box and name this as Periodic. Complete this by pressing Done. For completeness, drag out the comment box, title it Nodes, and enter a helpful command for future reference. Click Done. Then click Deploy to save the changes and start the flow. And now, because of the settings in the Inject node, every 3 seconds Hello World appears without our intervention. We have seen how nodes are connected into flows. We have seen how nodes in a flow are configured and experience the operating style of Node-RED using the Deploy button to save and initiate the flow. Node-RED, as provided with the Pi, has some specially customized nodes situated at the base of the palette. Let's drag these in and see what they can achieve. For this demonstration, I've added a push button to physical pin 13 of the GPIO port on the Pi, and an LED to physical port 12. I say physical pin as there are, rather confusingly, 3 differing numbering schemes for these pins. Starting with the LED, drag out the Pi GPIO. Now notice how this node has an orange triangular warning on it. This indicates that it's missing vital setup information. Double click on the node and we can see that it needs to know which pin it is talking to. The pull down allows pin 12, also known as GPIO 8, so select that. I'm not going to set an initial value, but let's call it LED and complete by pressing done. The orange triangle is now cleared. To keep things simple, let's add 2 inject nodes, one to provide a 1 in a string and the other to provide a 0. One to turn the LED on and the other to turn it off. Deploy and press the extensions on the inject nodes. 0, 1. This may not seem to achieve much, but there's a warm bloom of success the first time you set it up and get it working. Notice also this helpful little indication just below the LED node. This is really quite a delightful package. Drag in the button. Again, the orange triangle is visible, warning us that it's not set up, and so follow the now familiar routine. Double-click and select pin 13, GPIO 27. Call it anything you wish, but select the pull-up from the resistor option. This ties the input definitely to high or 1 when the button is not pressed, and stops it flapping around. Connect the button to the LED and deploy. The blue circles disappear, and if I can get my gnarly old fingers around this little header, I can show you the LED going off as I press the button. And the little indicators also showing up beneath the nodes on the screen. Just for good measure, we can add a debug node. Deploy and Shazam! Although this is trivial, it fulfills the first part of our IoT requirements: input, output to and from the device. Obviously, we are just using a push button and an LED here, but we could be using anything: a motor, a light sensor, GPS device, dare I say, kettle or a toaster. Quite rightly, there's been a good deal in the media over the last few weeks about IoT and security. A lot of scare stories about refrigerators taking over the world, but given some of the other options presented to us recently and our ability to choose, well, I'd bet my Dyson any day. Having mentioned security, what if this button were connected to some security device here? Can I email or tweet its status? Under Social, drag in the Twitter node. To remove the orange triangle, double-click and click on the small pen button. A further panel appears. Click to authenticate with Twitter. Press the button, wait for the approval, entering your details as required. That browser tab can now be closed once confirmed. Add the option. Deploy. Now a tweet is sent when the button is pressed. It's that simple. It's easy to send an email too. In the same manner, drag out the email node, complete the registration, deploy, and email. I've never seen such a simple yet powerful interface. And as they say, there's more. Drag in the Twitter node. I'll name it Twitter for incoming BBC One. Press done. I'll drag down a debug and connect it. Press deploy. To be flooded by incoming tweets. Go and grab a trigger node. This produces a digital pulse. Select the period. I'll choose 2 seconds and now complete. Press done to confirm. Drag the trigger over. Pull down the LED. And reconnect it to the output of the trigger. Now, when we press deploy, the Twitter is shown in the debug. Or select any subject to search for, so the LED pulses for 2 seconds every time a tweet is received. Extensible and open means that this interface can be expanded to include third-party applications. Here is one that's not in the mainstream Node-RED development, but runs closely in parallel with it, and it's a breeze to import and employ. Click on these bars here to reveal the pull-down menu. Select Manage Palette to cause the palette to reveal 2 tabs, Node and Install. Clicking on the Node tab reveals the list of nodes already installed. Clicking on Install reveals the wonderful world of extensibility and all of the efforts others have put into developing the community. Investigate this later. Enter Dashboard into the search bar and click on the Install button in the Node-RED Dashboard option when it appears. The package will be downloaded and installed. Press Done once this has completed. On some occasions, I've had to restart Node-RED and restart my browser for these changes to be fully reflected on the desktop. But hey-ho, what changes there are. Scroll down to the new Dashboard section in the palette to see the new set of nodes that control the UI, or the user interface. Here is a complete set of tools that allows you to set up a web page that includes sliders, buttons, graphs, gauges and forms, and map them back to your Pi, or any other item on the web. By dragging these into the flow and configuring them, you now have the same control over your Pi as we had earlier from the desktop with the Inject node. But this is now all available from a web interface. When the dashboard was imported, you may have noticed the third tab appearing on the left-hand pane. Click on the dashboard and this button. It opens a new window with your button in it. Click the button. If you have a mobile device, go to that and enter the same address into your browser, replacing the 127.0.0.1 with the IP address of your Pi. The same button appears. You now have remote access of the LED on your Pi from your mobile. Explore the dashboard to discover the full range of facilities. If a page becomes too crowded, you can start another by pressing this plus sign in the corner. It opens a new tab, and these can be selected across the top of the page. Pages can be renamed by selecting the page and then the menu button, and configure flows. Add, rename and delete are the options here, but beware delete. It's instant. There is no "are you sure" protection. You can also share your designs. Clicking on the menu icon again reveals the pull-down option from which you can select Export and Clipboard. The complex flow in the graphical design has been reduced and saved as a text file. You can see a small glimpse of this in the compact and formatted modes. This format is called JSON, which is the data format closely linked to the JavaScript language that Node-RED uses. We cover JSON and this formatting later, but for now you are able to export your design to the clipboard and paste it in the same way as you would handle an image or an MP3 audio file. Exporting and sharing is therefore easy and encouraged. We're going to be doing a lot of this in coming videos. Importing is just as easy. Take as an example a design directly lifted from the node-red.org website. Copy it into the clipboard and paste it into Node-RED. Menu, Import Clipboard. You are offered the opportunity to import into the current flow or a new flow. Either way, the imported code is converted into a graphical flow. When this code is run, it interrogates and presents data in the debug tag taken from this web page that is continually updated with live data about electricity flow in the UK. I claimed at the start of this video that you can avoid code entirely, and that's fine, but for those who want to dabble, here is a good entry point. It's called JSON. JavaScript Object Notation. The complexity of the flow was described in what appeared to be this block of code. It's not initially easy to read, particularly when it can all be seen on one line in what is called a minified format. The minified format can be copied into other web pages that just reformat. It still may not mean much, even in this more readable format, but it's the key component for parsing data. It is a lightweight human-readable format, and note that JSON is the notation format for data. JavaScript is the language used in Node-RED, and for those who do want to jump straight in, you can enter JavaScript directly into nodes like the function node. To do this, you should cooperate with the whole basis of Node-RED, which is that it operates by sequentially passing a message between nodes in the flow. The message carries the payload, and the nodes can be used to examine the payload. Mouse over these functions and realize that this is a large message switching center. This node changes the content of the message. And this one decides which route to follow by switching based on the contents of the message. These nodes split, join, and then convert the range of messages. To summarize this section, we've been introduced to Node-RED. We've seen how the graphical design connects the nodes into flows. We've seen how the requirements of the nodes are satisfied, and how these are deployed into action using deploy. We've seen a large range of capabilities such as direct control of the Pi using its inputs and outputs. Node-RED sequentially passes a message with a payload between nodes. Nodes can examine, manage and direct payloads. Messages can be read from websites or used to generate websites. Messages can easily be sent to messaging systems like email and Twitter. We have seen access to a vast and growing library of other nodes and flows that are easy to access and integrate, and how designs can be imported, saved and exported in JSON. Investigate the wider palette. There are some phenomenally frightening capabilities emerging, and if I were to be a more wicked person, In the previous sections, we described a typical connection configuration and demonstrated the power of Node-RED, causing an LED to flash on the Pi each time a term was mentioned on Twitter. It wasn't just the fact that this links hyperspace directly to some hardware here on the desk, but the ease with which it was achieved. I'm not now going to confess that it was all achieved using smoke and mirrors, and to prove it, you could skip to the next section entirely and carry on using Node-RED as you currently find it on your Pi. Several changes have had to be made to this video, even during its production, to keep up with some of the more recent changes. After all, Node-RED has only been available for 3 years. We will press ahead undeterred, but suggest that you keep a close eye on all of the version numbers, updates and upgrades. This procedure documents the best attempt to provide an installation to work with, or at least provide a solid path to follow to update any installation. We start with the most up-to-date installation based on the most recent Raspbian image issued by raspberrypi.org on the 23rd of September 2016. Insert your newly flashed microSD card and power up. The system is shocked into its initial boot and will take a little time on this first occasion, but will finally arrive on its impressive new desktop. The first step, as with any new card, is to personalize and secure the installation. You have the options in the Pi graphical interface of clicking on Mouse, Preferences, Raspberry Pi Configuration, or clicking on this terminal icon. I'm getting too old for more changes, so I'm going to use the latter option. Open the window and enter. Sudo raspi-config to reveal the trusty old setup screen. Override these options to suit your local requirements, but a standard install would include the following. I think option 1, expand file system, has already been carried out by the system when it first boots, but let's select it to be sure. Option 2, change user password, is a must. Select this and enter and re-enter your new password. Option 3, boot option. I prefer to set this to B1 for a standard text console login. Option 5 provides the internationalization option, and 9 advanced options leads to another array of choices. A2, set the host name. Change this to suit your local requirements. I'm going to use Node-RED in this example. By default, this name appears as part of the prompt and provides useful confirmation when logged into several machines simultaneously. Selection 9, again, A4 SSH, is enabled by default and allows you to use a terminal emulator to log into the Pi from another machine. This is highly convenient, although it's enabled by default. Enable A5, the VNC remote desktop viewer, A6, the SPI support, and A7, the I2C support. Tab down to finish and reboot to incorporate these changes. Log back after the reboot. The new hostname displayed in the prompt should confirm that this change at least has been accepted. As an initial check, the version of Node.js is installed is confirmed by entering node-v. It's interesting that the default version shipped with the 23rd of September 2016 distribution is 0.10.29, and npm is not installed at all. We'll come back to this shortly. Okay, first we need to do a firmware upgrade, so enter sudo rpi-update. My Pi appears to be a cray here by the magic of video. I'll cheat by speeding this up. It takes 3 of your Earth minutes in real time, after which
a reboot is required.
I'm sorry, I'm not entirely sure what happened there. Back from the reboot, do an update. So, sudo apt-get -y update. The -y flag enters the default yes to any question presented by the update and saves you having to confirm any change individually. This takes a minute or two to do, unlike the next stage. Sudo apt-get -y upgrade, which can take over 30 minutes, depending on your link speed. There are normally no problems here, apart from this challenge, where lightdm.conf is the graphics greeter, so I accept the default. Once completed, reboot, and then get down to some real changes. This completes the process of completely updating any standard edition. It takes time, but at least you know you're up to date with the basic packages. The whole process could have been speeded up by removing the unwanted packages before the update, but hey ho. Anyway, let's progress our own particular requirements of the Node-RED install. Node-RED uses Node.js, and Node.js requires updates, and we need a convenient install process. We need the Node Packet Manager npm, so sudo apt-get install npm. I should have included the -y flag. This took 2.5 minutes. Now we use the newly installed npm to grab and install version 2 globally. So npm i-g npm at 2.x. Then add sudo npm install -g npm node -gyp to keep all the versions aligned and up to date. This takes about 3 minutes. Node-v shows a dramatic leap to version 7 and the packet manager to version 3.10.9. Great! We are now ready to go. As a side note, you can make an image of the SD card in its present state and use this as the basic platform for future installations. It will save the hour taken so far. So that's it. Your Pi is updated and upgraded to within an inch of its life and should now be ready to run Node-RED. But before we do, let's add one further concept that is key to the part of IoT. It's another open source development from IBM, and it's called MQTT, Message Queuing Telemetry Transport. It may not be immediately obvious as to why MQTT is needed, as it just sits in the path of sensor data and is another element that has to be learnt, understood and manipulated. If we have a Pi that's used to read, say, brake temperatures on cars, each car has a Pi then connected back to a main Pi that amalgamates the massive data from all cars as part of a product development program. Establishing a link between the Pis is initially quite simple. A few connections is easy to cope with, but becomes more and more arduous as the number of sensors increases. The task grows and eventually becomes unmanageable. It's said not to scale. And with IoT involving millions of devices, scaling is essential. With MQTT, all of the sensors are connected to a data broker. They become clients of the broker and publish their data to the broker and label their details as topics. Interested parties, also called clients, then subscribe to topics that they are interested in. In this way, the direct link is uncoupled and the flexibility of having many subscribers to many published sources is established. The broker acts as a clearinghouse, collecting published topics and distributing them to interested subscribers. It's dynamic. Links can be removed and introduced, new topics added and old ones removed. It's very flexible. A task of the broker is to prioritize data and ensure a quality of service is sustained. Some important data, referred to as Class 2, must be guaranteed to get through only once as a single copy, but the lower Class 0 is volatile. It does not matter and may be lost in transit, only to be updated with the next arrival. As MQTT is so important, and in the general spirit of these videos of let's learn by doing it ourselves, we're going to install and test our own copy of Mosquito, the chosen open source MQTT server. At the time of production, the normal installation route for the Pi using apt-get is a little behind time, so the quickest and most reliable route is to add another more up-to-date repository and download from there. The process is first to grab the key of another repository, so sudo wget. Add the key that's been received, sudo apt-key add. Change directory and get to the list. cd/etc/apt/sources.list.d/ grab the list. Sudo wget. Do the update. Sudo apt-get update. And install the 3 packages: Mosquito, Mosquito Clients, and the Python link to Mosquito. And install. All pretty painless so far. To test the newly installed server, start it if it hasn't already started. It usually does. Sudo /etc/intid mosquito start. The simple way to test a server is to subscribe as a client, and in another screen publish as a client. We can do this from the command lines like this. So open 2 sessions. The first is to subscribe. So sudo mosquito subscribe. This is a subscription to anything referenced under the topic Hello World. The command is acknowledged. In the second screen, let's send as a client a message with the topic Hello World. Thus, sudo mosquito client, topic Hello World, hello from terminal window 2. And our 29 bytes of data have been transmitted and received. That ends this slight diversion into MQTT. The fact that this server is now running in the background means that future testing is simpler. No reboot is necessary. Although Chrome is now the basic browser shipped in a standard edition of Raspbian, and the Pi is a powerful device, it is probably better if you use it in what is known as the headless configuration. This means that the Pi concentrates on the task it performs efficiently and offloads all client functions to another machine. It means using the Pi as a standalone device and controlling it remotely. It's a common configuration, and we will show you how to set it up here. In a Pi-only configuration, we could log into the text-only mode and type startx to start the graphical user interface. We need a graphical user interface, as that's where the power of Node-RED exists. To start Node-RED, simply click Menu and then the Node-RED icon that started this video. To see the Node-RED desktop described in the earlier section in this video, simply follow the instructions in the console window that seem to stop. Open a browser and enter either http://localhost:1880 or http://127.0.0.1:1880. 127.0.0.1 is the special me address. This is the direct link into the Node-RED desktop. Although this works, it's possibly not the best and most nimble solution. Open a browser on another machine and point it to the address presented in the console on the Pi. This will typically be something like http://192.168.0.something:1880. The Pi 3 has potentially 2 useful addresses that can be seen by mousing over the interface icon at the top of the desktop. If you have local Wi-Fi access, you can click on the Wi-Fi link and associate it with your home router. This will provide a second IP address for your Pi. Now you can point your browser at either of these IP addresses, but ensure that the :1880 is added after the address, as this is a special Node-RED port, not the standard port 8 you'd have for HTTP or 443 for secure HTTPS. Once you've established this link, you can control Node-RED. Now, just consider the connection options that already exist. If your Pi and the remote machine are connected by Ethernet, you are both connected via cable. If either the Pi or your remote browser are connected by Wi-Fi, then a wireless connection is also used somewhere. If you want to control the Pi from a console screen via a Windows machine, then it's safe to search Google for PuTTY and install a copy from any of the top 3 references. PuTTY is a secure, encrypted terminal connection that uses port 22. When it is opened, you can log into your Pi from a terminal on a Windows desktop. Apple devices have suitable terminal emulators already installed. If you're a Linux user, you don't need telling. You're obviously wise enough to make the link yourself. At some point, you're going to be irresistibly drawn to control your kettle from the other side of the world. And the good news is that this is easily possible with the technology that exists today. Care has to be taken, though, in order for this situation not to end up in the bad news column. All of the graphics so far have concentrated on a typical setting at home on the LAN, the local area network. The home router is the central component in connecting the LAN to the rest of the world, the WAN, the wide area network. The router has a number of functions. One is to share the single real-world IP address that's been assigned by your ISP, your Internet Service Provider. It does this by generating a different range of private IP addresses and allocating them to the devices in your home by Wi-Fi or cable connection. Another function is to manage the flow of data across the LAN-WAN interface. Outgoing access to the WAN is generally open. It may be restricted by parental guards, but it's generally open. Inbound data from the WAN poses a major threat, which is why software, alarmingly called a firewall, is programmed to provide protection. A description of the firewall is beyond the scope of this video, as is any hope of describing how it's changed. There are just too many differing models of routers to describe, but they are generally accessed by pointing a browser at the default gateway address. It's always interesting to search through the options and read through the log files that explain what the router is protecting you from. If you don't consider this too daunting, you can continue by finding the section on port forwarding. Port forwarding allows you to map the private internal IP address of your Pi to the public WAN address. Correctly set up, your friends, or enemies, can putty into your Pi using your public IP address from anywhere in the world. You could also try running a web server by exposing port 80, but do take care. You could then expose the IP address of your kettle to the outside world, along with any other smart TV, baby alarm, security system and refrigerator you may own, but don't. Here is a prime example of the use of the MQTT server. Rather than peppering the firewall with multiple settings, just add one. The MQTT service operates on port 1883, and if you follow the standard settings, only this message service is connected through the firewall. All of the devices in your home could then be programmed to listen to this one service. Do ensure that you add authorization to the MQTT server described earlier in this video before you use it in anger. Those alarm bells are the exit cue for this video where Node-RED on the Pi was introduced. I hope that it's been helpful and encouraged you to look more closely at Node-RED. The repeated warnings about version numbers should be observed, as inexplicable failures can be demoralizing. Our extended installation description should help you circumvent these. Playing with nodes and what they can achieve is fascinating. Importing further libraries of nodes and flows extends the basic capability. A huge range of really impressive interfaces can be designed using imported systems, but at some point the inquisitive will discover JSON data structures and object-oriented programming in JavaScript. These are the subjects covered in the next video.